Lesson: Understanding Bias in AI Models. Understanding bias in AI models is a critical component for professionals aiming to implement ethical and fair artificial intelligence systems. Bias in AI occurs when the algorithm produces prejudiced outcomes due to preconceived notions present in the data, model design, or application context. This lesson aims to provide actionable insights and practical tools to address and mitigate bias, enhancing fairness in AI systems. AI models are trained using vast datasets, and biases can emerge at any stage of their development. These biases often reflect societal prejudices, as the data used to train AI models frequently contain historical biases. For example, a study of hiring algorithms revealed that certain models favored male candidates over female candidates, reflecting historical gender imbalances in the workplace. This instance illustrates how biases in training data can perpetuate and exacerbate existing inequalities. To counteract such biases, it is essential to use comprehensive and representative datasets. One practical tool to achieve this is the use of synthetic data generation, which can help create balanced datasets that reflect a more equitable distribution of demographic attributes. Frameworks like the fairness, accountability, and transparency in machine learning provide guidelines for identifying and mitigating bias. These frameworks emphasize the importance of transparency throughout the AI development process, encouraging practitioners to document decisions made during model training and deployment. This documentation is crucial for assessing how decisions might introduce bias and for facilitating third-party audits, which can highlight areas for improvement. A step-by-step approach to addressing bias begins with the pre-processing stage, where data should be thoroughly examined for signs of imbalance or unfair representation of certain groups. Techniques such as reweighting or resampling can be applied to adjust for these imbalances. For example, if a dataset used to train a facial recognition system contains predominantly images of light-skinned individuals, the model may perform poorly on darker-skinned individuals. Resampling techniques can help balance the dataset, improving model accuracy across diverse populations. Once the data is prepared, the model training process requires careful consideration of fairness constraints. Tools like IBM's AI Fairness 360 and Google's What If tool provide interactive platforms to test models against various fairness criteria. These tools allow developers to simulate different scenarios, analyze model performance across different demographic groups, and adjust models to enhance fairness. By incorporating fairness constraints into the model optimization process, developers can produce more equitable outcomes. Post-processing techniques also play a crucial role in mitigating bias. These techniques involve adjusting the model's predictions to ensure they meet fairness criteria without altering the model itself. For instance, the equalized odds post-processing method aims to equalize the false positive and false negative rates across different demographic groups. This approach is particularly useful when bias is detected after the model has been deployed, allowing practitioners to make necessary adjustments without retraining the entire model. Real-world case studies highlight the effectiveness of these tools and strategies. In a notable example, researchers applied fairness constraints to a predictive policing algorithm, which historically targeted minority communities disproportionately. By adjusting the model to account for fairness constraints, the researchers were able to reduce the algorithm's bias, leading to more equitable policing outcomes. This case study demonstrates the potential of fairness frameworks and post-processing techniques to address systemic biases in AI applications. Understanding bias in AI also requires a cultural and organizational shift towards ethical AI development. Organizations should foster a culture of inclusivity and diversity, encouraging teams to critically assess potential biases in their models. Training programs that emphasize ethical AI practices can empower developers to identify and address biases proactively. Additionally, organizations should establish clear accountability structures, ensuring that teams are responsible for the ethical implications of their AI systems. It is crucial for professionals to stay informed about the evolving landscape of AI ethics and bias mitigation. Engaging with scholarly literature, attending conferences, and participating in professional networks can provide valuable insights into emerging trends and best practices. By staying informed, professionals can anticipate potential biases in their AI systems and implement proactive measures to address them. To conclude, understanding and addressing bias in AI models is a multifaceted challenge that requires a combination of technical expertise, ethical considerations, and organizational commitment. By leveraging practical tools and frameworks, professionals can identify and mitigate biases in their AI systems, promoting fairness and equity. This lesson has outlined actionable insights and strategies, offering a comprehensive guide to understanding and addressing bias in AI models. By implementing these strategies, professionals can contribute to the development of more ethical and responsible AI systems.